In this video, I'm going to explain how to complete Activity 6. This is the activity that we were planning to complete in class today. So first I need to explain what we would have done if we had been in class today. I was going to have us do a recall experiment, a memory experiment as a class. I was going to randomly assign you to two separate groups, and I was going to present the first group with one type of a slideshow, and the second group with a different type of a slideshow, and we were going to look at which group does better on the recall test. So let me show you the slideshows that I would have presented in class for you to memorize. So, group one would have gotten a list of, group one would have watched a list of two-digit numbers in ascending order, which means ordered from lowest to highest. So group one would have watched these numbers one number at a time. These numbers would have flashed by one number at a time. And at the end of the slideshow, group one would have been asked to write down as many of these numbers as they can recall in any order that they remember them in. Then, after group one is finished, I would present the slideshow to group two. Group two would watch the same list of numbers, but in a random order, like this right here, a shuffled order. Then at the end of the slideshow, group two would be asked to write down as many numbers as they remember in any order. And after both groups finish the recall test, I would ask each student to score himself or herself. So to score yourself, you would have just looked at the list that you memorized and count how many numbers you were able to remember. So let's say that you look at your list of, you look at your recall sheet of what you wrote down, and you see that you remembered 12, 19, and 25. And none of these other numbers ever appeared in your memory. Well, then your score would be 3. You got 3 out of 12. And let's say that you look at your recall sheet and you see that you remembered 12, 25, 28, 57, and 81. Well, that would mean that you correctly remembered 5 out of 12. Your score would be 5. So every student was going to get a recall score between 0 and 12. If you couldn't remember any of them, you would get a 0. If you remembered all 12, it would be a perfect 12. And after each student scores himself or herself, I was going to have us enter all of our recall scores into a website that would calculate some statistics for us, and it would tell us if our hypothesis was supported. Our hypothesis was that the group that's recalling them, the group that watched them in ascending order would do better than the group watching them in random order. Our hypothesis was that the ascending group would do significantly better than the random group, and I think that's what you would I think you would probably agree that that's what what we would expect, right? It kind of makes sense that the ascending group should do better than the random group because it's difficult to recall numbers in random if you've watched them in a random order. So let's go through these questions. So since we're not actually doing the experiment, I'm going to have you make up your own data set. So you have to make up recall scores for the ascending group and recall scores for the random group. And then go to, you're going to be using this website right here. So go to Google and type in GraphPad t-test calculator. So if you actually type in 2-sample t-test calculator and go to GraphPad t-test calculator, it's the first result. So a t-test is what you use if you're doing an experiment with two groups, like ascending and random, and you want to know if the mean or average score of one group is significantly higher than the mean of the other group. So if you're looking at the mean of group 1 and the mean of group 2, and you want to know if there's a significant difference between the two means, you would use a t-test. It's one type of statistical test that's used in research. So a t-test would be appropriate for our experiment because we are looking at the means of two groups. So here we have group 1 ascending, group 2 random. I need you to make up 20 recall scores for ascending and 20 recall scores for random and fill them in. Remember, each recall score is something between 0 and 12, right? Because each student in our class was memorizing a list of 12 items, right? So any number between 0 and 12 is allowed. But try to make the numbers as realistic as possible. So don't make them all the same number because that's not realistic. In an experiment, there's always going to be some variability between different participants. But if you agree with me that the ascending group would do better on average, then just make the ascending scores a little bit higher on average. So maybe enter in maybe a few tens every once in a while, and maybe a 9, but then mix in some lower ones too, because maybe some people are tired, or maybe they didn't take the task seriously. But maybe if you agree with me that ascending is easier, then make these scores higher on average. And go all the way down to 20. And then make up your own list of scores for the random group. And if you agree with me that they would do more poorly, just do your best to make the scores lower on average. They don't all have to be low, but make them lower on average. Then, once you have all of your scores filled in, go to Calculate Now, and you'll get your results. So, what do you actually need to know if you have a significant difference is something called the p-value, and I'll get to that in just a moment. But now let's go back to these questions for the activity. So the first one says, which group performed better at the recall task? Well, you just have to look at your results from your made-up data set. So let me look back at mine. Well, it looks like for me, the mean for ascending was 8. The mean for random was 5.2. So in my data set, the ascending group did better and random did more poorly. That would be my answer. But for you, it might be different. Then, because you're making up your own data set. This one says, is the difference between the mean recall score of ascending and random statistically significant? Well, you have to check the p-value. If p is 0.05 or less, then it is a significant difference. So if p is something like 0.02, 0.03, 0.04, that's significant. And if it's exactly 0.05, that's significant. But if it goes above 0.05, like 0.053 or 0.06 or 0.07, that's too high. It's not significant. It has to be 0.05 or under to be significant. And the reason why the 0.05 cutoff is used is because it goes along with the idea of being 95% confident. If you get a p-value of 0.07, you're only 93% confident, and it's not good enough. But if you get 0.05, you're 95% confident, which is good enough. So, so in my case, in my data set, I would say yes, it is significant because my p is low enough. Mine would be a yes. And it says, if the difference is significant in your made-up data set, explain what that means. And if it's not significant, explain what that means. So if you end up getting a significant difference, then what you would say for question 3 is, I'm confident that the presentation order did have an effect on memory. So you would say, I'm confident that the difference in recall between ascending and random isn't due to chance factors. I'm confident that the presentation order actually had an effect. Um, and if it's not significant, what you would say is the opposite. You would say, I am not confident enough to say that the presentation order had an effect. So statistically, if a result is statistically significant, you're confident that it's not due to chance or chance factors. So just do whatever wording you need to do based on your result. The next part says, do your results match the results of Houston 1976? So Houston actually did this experiment on ascending and random numbers. And in Houston's experiment, there was a 2-point difference between the mean of ascending and the mean of random. I believe the mean score for ascending was 9.5 and for random 7.5. So ascending did 2 points better on average. So just describe if your result seems consistent with that outcome or if it seems different. This says what extraneous variables were controlled in our experiment. So for question 5, you just have to imagine that we actually did this experiment in class. So let me describe what we would have done. I would have presented I would have timed the presentation rate so that every participant saw the numbers at 2 seconds per slide. I would have shown everyone the same list of numbers, just only the presentation order would vary. I would have given everyone the same amount of time to attempt to recall the items. Everyone would have taken the task at the same time of day during class. So everyone would have taken the test in the same room. So anything that's held constant and is controlled. So anything that's exactly the same for all participants is controlled. So if all participants take the test at the same time of day, then that's time of day is controlled because it's the same for everyone. If everyone is given the same amount of time to recall the items, then that variable is controlled because it's the same for everyone. So I'm just trying to give you examples of things that I would have made equal for everyone, things I would have held constant. So an extraneous variable is something that's not being studied but could affect the data. So things like time of day or like the number of distractions in the room are all extraneous variables. They're all things that could throw off the data, and they're all things that are not being studied. And so yeah, an extraneous variable is not being studied, but it could affect the results if it's not controlled. So for question number 5, just list out some of the things I've just described, things that would have been controlled if we had done this in class. This one says, what if the ascending group just had better memorizers than the random group? Well, what this is, um, um, so it's if we did this experiment and the ascending group did better than the random group, and we described our results to someone else, that person might come back at us and say, well, how can you be how can you confidently say that the ascending order um, made them do better? Because what if that first group simply had people who were better at memory in general? Um, what if group one would have done what if group one would have done better regardless of what order they got the items? What if they were just really good at the task? Um, I want you to think about what we would say back to that person to try to make that other person confident in our results. Um, to try to, I want you to think of what we would say back to that person to try to sort of make them as confident as we are that the ascending order is what actually had an effect. So basically, how would we defend our experiment to that person and sort of back up our results and defend ourselves against this um, against this possible interrogation, I guess. And this um, what I'm looking for here is actually something we've been talking about for a while. So, um, or since the very beginning of the semester. Um, so hopefully it's clear what I'm looking for in this answer. Just let me know if you're unsure. Um, this one says, which of the following is correct? Um, the um, the results might be due to a chance difference. Um, let's see here. Actually, um, skip. You can skip question 7 and question 8. So, explain why our study isn't a non-equivalent groups design. Well, go back to type lecture number 6 and and review what a non-equivalent groups design is. Um, and also remember that in the experiment we would have done in class, I was going to randomly assign students to group 1 or group 2. Um, so just think about that, and then explain why it's not a non-equivalent groups design. Um, so what's the independent variable? Well, you'll need to refer to type lecture 7 if you are unsure what an independent variable is. So in an experiment, the independent variable is the variable that's changing from one condition to the next. So imagine that instead of testing presentation order, I was testing temperatures, and group 1 was in a cold room and group 2 was in a hot room. Well, then the variable that varies from one condition to the next would be temperature, right? Temperature is changing from condition 1 to condition 2, so the independent variable would be temperature. Or imagine that I was testing hours of sleep, and group 1 was getting 4 hours of sleep, and group 2 8 hours of sleep, and I was trying to compare their performance. The independent variable would be hours of sleep in that experiment because sleep is what's changing from condition 1 to condition 2. So um, so yeah, the independent variable is whatever is changing from one condition to the next, and it's what the researcher is basically testing. The researcher wants to test the effect of the independent variable to see if it actually does have the predicted effect. So think about the conditions ascending and random. Those are two different examples of something. There are two different levels of something, and whatever that something is the independent variable. So ascending and random are two types of something, right? So in our experiment, what are the levels of the independent variable? Well, this is also in type lecture 7. So the levels in an experiment, the levels of the independent variable are the conditions that the people go through. They're the actual conditions that are being ran. So our two conditions are ascending and random. So those are the levels of the independent variable. So just provide the names of our conditions for this question 11. Um, so yeah, ascending and random are the levels, and whatever they are the levels of is the independent variable for question 10. Question 12, what's the dependent variable? Well, if you look at type lecture 7, you'll see that the dependent variable is the variable that's being recorded or measured by the researcher in order to look at the effect of the independent variable. So um, the researcher records the dependent variable to see if it was actually impacted by the independent variable. So let's see. In this experiment, I would have been recording each person's recall score, and I would do that to see if recall depends on presentation order, to see if recall is impacted by presentation order. So that should help you get an idea of what the dependent variable is. So we used a non-random convenient sample that was almost senior psychology students. Well, if we had actually done the experiment in class, it would have been a convenient sample of all psychology students. Explain why this is a weakness of the study. So um, it's actually a problem. It's not an internal validity problem um, because it's not going to, this isn't going to keep us from concluding, it's not going to keep us from reaching a conclusion about the presentation order's effect. Um, it's simply going to affect our ability to generalize our conclusions to a broader population, right? So if we have a non-random convenient sample, then we don't have any children in our sample. We don't have any older people in our sample, like people above 65. Um, we don't have um, we don't have any non-students in our sample, um, so we can't reach any conclusions about those types of people, right? We can't generalize beyond the people that were actually tested. So it's more of an external validity problem, right? So yeah, even if the ascending group does significantly better than the random group in our class, um, we can't confidently say that the ascending order would have the same effect on people who were not actually represented, like children or anyone else, right? We can only reach the conclusion for college students. So our study had um, did it have random sampling only, random assignment only, or both, or neither? So think about if we had actually done the study. Well, so random sampling means random selection, right? Like selecting people with a random generator. Well, if I'm just taking the students who happen to be in my classroom and having them participate, is that really random selection? Am I really using any type of generator, or am I just sort of hand-picking people who happen to be nearby? Um, Now, if I'm taking my participants and randomly dividing them into two separate groups, that would be random assignment, which is done in every experiment. Um, Now, I have to quickly explain what I did last semester with my class. So, when I did my experiment last semester, um, what was the confounding variable? So, a confounding variable is um, something that's uh, not controlled like it should be. Um, and it's something that has the ability to skew the results. It's something that sort of undermines your confidence in your results, right? So let me explain what I did last semester. So what I did was instead of presenting the slides on a slideshow, I actually read the numbers out to the class. Um, so first I read the ascending list to group one. I had them then I had them recall what they could recall. Then I read the random list to the random group and had them attempt to recall. So what actually ended up happening was the random group ended up hearing the numbers twice because they they were listening when the ascending list was read, and they were also listening when the random list was read. So at the time when they actually tried to recall the items on paper, they had actually heard the list twice already. Whereas when group one, the ascending group, was recalling the items, they only heard it once. They only had one chance to hear it. So yeah, the ascending group heard it once, the random group heard it twice. So think about what variable was not controlled like it should be, like it should have been, and that is the confounding variable. The confounding variable is the unwanted difference. So think about, in what way do you think the confounding variable affected the results? Well, um, if the random group heard it twice and the ascending group heard it once, just think about which group had the unfair advantage, and that would be the answer. And here I just want you to do a couple of things for question 17. So I want you to, first of all, make a bar graph showing the means of the two groups in your made up data set. So just make one bar for the mean of ascending, the one bar for the mean of random, um, based on your output from the website. Then what I want you to do side by side is make a graph of what you think the results looked like last semester when we had this confounding variable and the random group heard it twice. Um, so the reason I want you to do this is for you to try to think about how the confounding variable would have skewed the outcome and sort of affected the results last semester. And it'll allow you to sort of compare them side by side. Um, yeah, and if you don't want to make a bar graph, I would be okay with it if you just um, gave me a table where you say something like this semester ascending uh, the mean of ascending equals blank, the mean of random equals blank, and then last semester mean of ascending equals mean of random equals. That's fine too. Um, as long as you can have a side by side comparison of the two results, that's fine. So just let me know if you have any questions about how to do this activity, and I'll set up the submission link, and it's due today at, well, it would have been 3 o'clock, but I'll set it to 5 o'clock just in case you need a little more time.